this video, we're going to go from this. To this, using this. Alright, so my ice maker has quit making ice, and I'm going to do a little troubleshooting here, and hopefully this will help you out. This will help you troubleshoot yours as well. So real quickly, if I get the camera in there or not, we're going to try. There is ice in there. So there is ice in here. If you reach your hand up in here, you can feel that there's ice, but it's not coming out. So it tells me real quick a couple of things that are most likely good. It's getting water in there, and it's cold. So I want to pop this open. This cover right here. And, oh, and by the way, these ice makers are used in a lot of different refrigerators. This happens to be a Whirlpool, but you'll see them in other models as well. Alright, so inside there are several test points around here, and they are labeled. I don't know if you can see it in the video or not. I'll probably post an overlay of it with them all marked. And then you have this wheel right here, and this right here, this mark with this right here, is basically at the home position, okay? So it's at kind of a start cycle of everything, or I guess the beginning of pushing it out. So just to go through the cycles real quick, just so you kind of know what's going on. So this is considered the 6 o'clock position right here. Right here, the thermostat opens, then the heater is off at that point, right? So right up here, approximately right here, is where the water valve is powered on to put water in. Then over here we have our eject blade stop position, and then right here approximately is the start position, and then right here ejector, stalls on ice, motor on, heater on. Okay, so that turns on the heater, and all that does is that allows the ice to be separated from the mold here and then pop on out, and then we just start the whole process all over again. So I suspect mine might have an issue with the heater because it's stuck in there and it's not coming out. A couple of checks you can do without a meter. Make a jumper like this. This preferably is made with a single core wire, pretty heavy gauge, because this is going to be 120 volts you're playing around with here. So make sure it's insulated. I've seen paper clips used and then wrapped with black tape. But whatever you do, make sure you protect yourself from being shocked. So jumping between T and H on a powered ice maker will simulate a closing of the internal thermostat, and it'll initiate a harvest cycle, powering the ice maker motor and the mold heater. So you just put it in there for about 3 seconds and then pull it out, and it should power on then. So that's between T and H. So if I'm gonna go in here, and T and H are these two right here, and again they are marked. I don't think it's showing up all well in the video. So we're going to put this right here, leave it on there for about 3 seconds, and this should start the process. Mine obviously has problems, so it's not going to. Then another test you can do between M and N, and that should power on the ice maker motor. So up here is N, and right here is M. So if I jumper between these two, between M and N, I don't know if you can hear it, but the motor is trying to run, but of course it's frozen because of the ice right there. So that's telling me the motor is most likely good. And then between H and N should energize the ice mold heater. H and N is up at the top. So between H and N, So you can see it's starting to rotate. And you can probably hear some crunching going on in there. I'm gonna go ahead and let it go through this just a little bit, just to see what happens. Yeah. Okay, so that's some quick checks you can do with just a jumper wire. No meter needed. Next, let's go ahead and look at some voltage checks that can be done. Okay, so next we're going to check between L and H, and we should see 72 ohms there. Okay, so next I'm going to check between L and H right here. There should be a resistance of 72 ohms, somewhere thereabouts, and that checks the heating element. Pop this in here, and we should see 72 ohms. Your beepage. There we go. So I got 72 ohms. So the heating element is good. Itself is good. Okay, I added a little light so I don't have to use my phone. So anyway, between L and M should be 4,400 to 8,000. And again, this is L. And by the way, L is simply line. That's your hot line voltage. N is neutral, right? So between L and M, which is the motor, okay, before you do the resistance check, I didn't think about this. Unplug it. So I got it all unplugged now. And again, between L and M, I'm showing 5 ohms, which, yeah, 5 ohms. So I am getting resistance, so the motor's good. And we already did the test on the motor, and it shows it's good. All right. Okay, and checking between V and N, we'll check the resistance of the water valve solenoid coil, which should be 300 ohms or so. And that was between V and N, so that would be here and here. Let's go ahead and plug into that. And I'm showing 197 ohms. So it's less than 300, but it's not a short or anything, or an open. So that should still be good. And the resistance between T and H should show continuity, 0 resistance. If the internal bimetal thermostat is closed, it will read infinite if open. So testing for voltage should show 0 volts if the office maker internal thermostat is closed, or 120 if it's open. So now we need to apply power back to it again and go back to voltage. Okay, so next we'll check the voltages there between T and H, which is this one and this one right here. I've got 0. And resistance shows as a short. Okay, so next I suspect I've got a bad module here. So I'll need to take it out. And to remove it, there's simply 3 screws and a plug. There's 2 that go in right here. They're quarter inch, so a 1/4 inch socket will go in there and pull it out. And there's one right about here. And I'll show those as I take them out. To pull the whole ice maker out. Now if you just want to pull this assembly out, 1, 2, 3, this pulls out. Make sure you have the power disconnected. Okay, so I've disconnected power, and now I'm going to take these 3 screws out. I guess I'll start with the hard one first. Awkward one. So that. That. Set these aside. By the way, the cover makes for a great place to keep screws. Now this kind of clips on with the electrical contacts here, so it's sometimes a little difficult to get it started to come out. See, told you so. And might as well get this out of the way. Oh, pull this out. Forgot about that. Mine does not release. I think it's supposed to release. Come on now. There we go. Okay, so this is actually the second time I've been into this one. My motor showed up as bad, and test confirmed it was bad. I replaced it, and looking up just the motor itself, I saw that this is the same as the timer on a dryer, and I just happened to have a dryer timer around that was good, so I swapped the motor out and actually fixed that. And to swap the motor itself is pretty easy. You just turn it like so and it pops out. You can see how these clips right here go into here. Just turn a little bit and pop it out, and then depending on your motor, pop these wires out and put them into the new one. Or if it comes with the wire on it, you can just go ahead and remove them from down here and check it there and pop them in there. Just to show a quick test on how to test that motor with it out so you're more reliable. This removes all those contacts and everything. Go in here on resistance. See if you can see that. Hopefully you can. Go in here on resistance and put it down to 20K. Alright, and then you can just simply put a lead here, and just so you can see it better up here, I'll put a lead right here as well. And I've got, what is that, 2 ohms? Or is that 2,000 ohms? Probably 2,000 ohms. Let's run it down here. Yeah, 2,000 ohms. Basically know what scale you're on, right? So yeah. So mine is measuring at 2,000 ohms, so that gives you something to check on yours. Okay, and let's to put it back in. Again, you got the little clips right here. It goes into these holes right here. Just put it in there. Little, I don't know, what is it, 1/16 of a turn, it locks in. So now the motor's back in. It is a 120 volt AC motor, so keep that in mind. See if I can get a better shot of these markers here. There's N, there's H, T, L, V, back up to N. So again, N, neutral, L is for the line. So that's your, across that, I don't think I mentioned that before. Across these two right here, you should have 120 volts. If you don't have 120 volts there, got something wrong with the refrigerator or that wire going up to it. So this unit may not even have any issues at all. It could be the power going into the ice maker. Neutral. N is for neutral, M is for motor, H is for the heater, T is for the thermostat, L is line, should be 120 volts on that at all times, and V is for the water valve. Okay, so upon further inspection of mine, I don't know if you can see this or not. Let me try to get this in here. Right there, maybe right here. Right inside there, there we go. You can see 2 contacts, right? There should be a little deal with contacts on both sides of it going between it. And there's not. It picks up down here where, on further down here where it broke off or burn off at. So, just happen to have this one that I ordered. This is actually a couple of days later, but not for you, just for me. And on this one here, two differences I did notice. And there'll be, of course, a link in the description for this part. This motor is much smaller. This is a 1.5 watt motor versus a 3 watt motor. That concerns me, but I bought it anyway. You can look right down in here. Hopefully you can see that okay. You can see there's actually the piece in the middle there. So that is what was wrong with mine. Now, with mine, this piece right here stayed in the machine when I took it out for the little lever. And it doesn't, oh, hang on a second. So on the machine, this piece right here is on my lever, and it feels like it's like molded into it. So I'm just gonna, this right here, oops, looks the same if I remove this piece off. So I'm gonna try that and see if that'll work on mine. There we go. I just pushed the tab in and pulled it out. Probably didn't do that on camera. I know how much you guys love it when that happens. So there we go. So now when putting it back in, this D shape's got to line up with the D shape in there. I'll show that in a second. And then this piece right here has got to line up with the little ice piece. Alright, so again, this D shape right here, it's got to line up with this D shape down here, which it should be, yeah, it should be lined up. And then I've got to line this piece up right here. This is the flag that I was telling you about. And basically, it should just pop in pretty much with it in the off or in the on position. So hopefully I can just pop this in there, put those 3 screws in, and we're good to go. So you can actually see that flag just a little bit through this hole right here. I think it went. All right, let's put those 3 screws in. And I'm going to plug it in before I put the cover back on. I see it turning. That's good. Halfway there. See that spinning, Ruby? Right here? See that?
Yeah, Daddy.
Hopefully when this dot right here gets down to here, it'll stop.
Oh.
Hopefully.
It's stopping.
Yeah, it should stop then.
So I think he's stopping. Stop. He's stop. The what? You see it? Yes.
I got here water going in.
water.
Yep.
Not going in. They you want to cook? Uh-oh.
No, that's how it's supposed to work. That's good. That means I got that.
Yay!
I got that connected.
Yay! Yay! Oh no.
All right, so the next cycle will take probably about 2 hours. So now just throw the ice bin back in it, and all should be good. Okay, so next, of course, put the cover back on it. We'll put the ice in it. All's working fine now. Thank you for watching. Hope you enjoyed this video. If you did, please select like down there and subscribe to my channel. If you didn't like it, well, subscribe to the channel. Maybe you like the next one. Thank you for watching.